All right, today we're going to talk about forest operations, and this is basically the process of cutting down trees in the forest and then the operation that's required to get those trees out of the forest into a place where they can be milled to create some sort of economic value, or at least a process where they can be taken out of the way so they don't provide a continued fire hazard in the place where they may be lying on the forest floor. So usually the tasks are broken up into 4 categories. The first task is felling or cutting down the tree. And then the second task is moving or extracting the tree. So taking it from where it was standing to some sort of landing site or some sort of site where you might be processing and loading the tree onto a truck for a longer transport. Then the third task is to process the tree, so that involves kind of taking the tree and turning it from a whole tree into the bole of the tree, which is usually the part that you're trying to get out of the forest. So that involves cutting off limbs, cutting off the top of the tree that will be too small to process, or bucking up the tree to length. So maybe that's a 16-foot length or a 32-foot length that you're trying to create boles out of. Then you have to load the logs onto a log truck or some other thing that you're going to use to take them out of the forest. And then finally, you have to transport the logs from the site where they're being loaded to usually a mill, maybe a biomass plant, or some other location that would be less typical. Okay, so there's different ways to approach all these different tasks. The first task, felling, which is, as we already said, cutting down the tree, can be done in a variety of ways, like all the other tasks. And the first way, the most old school way, is by hand. And back in the day, of course, they did this by hand with like axes chopping into trees, and that was, you can imagine, a very labor intensive process. And today when we cut down trees by hand, it's almost always using a chainsaw, and we saw this a little bit on our field trip. So there's different reasons why we might choose to use a chainsaw. Maybe the tree is very big, and so we can't really get mechanical equipment that is capable of cutting down such a big tree. Often trees that are bigger than about 30 inches or 36 inches, 3 feet in diameter, are handled with chainsaws. Maybe the ground is really steep, and so we can't get equipment in there. Or maybe the trees are spread out in a way that it's not really efficient to bring big equipment in. So there's a variety of reasons that we might use hand felling techniques rather than mechanical techniques. But increasingly, mechanical techniques are commonly used in forestry, and there's different tools that are used to cut down trees in the forest. And a general term for a lot of these tree cutting down machines is a feller buncher. So what a feller buncher does is it basically grabs the tree and then uses some sort of blade, often a chainsaw blade or a round blade, and cuts off the tree at the base. So there's different brands of these things. Timco is a common brand, but there's many other companies that make these things as well. And like I said, there's different kinds of blades. The machines are also on different kinds of footing, so they may be wheeled, like the picture in the top of the screen here, where they're on rubber tires, and they might have a little bit more agility to move around in the forest on wheels, or they might be on tracks, where they may be doing a little bit less soil disturbance because the weight of the machine is spread out over more ground area, which is hopefully designed to minimize soil compaction, but then they're not going to be quite as agile, quite as able to move around in the forest as cleanly. So that's what a feller buncher does. And then a harvester is something that does the work of a feller buncher, but then also has additional capabilities to kind of move into the processing stage as well. So it might then also limb and buck up the log at the same time that it cuts it. So anyway, this process of using mechanical equipment is generally considered to be something that has improved the way that we're able to manage forests. Because we're able to cut down more trees over a greater area more efficiently, this allows us to basically focus on cutting down smaller trees out of the forest that it might not have been economically efficient for us to remove if we were just depending on hand fellers. So we've talked in class before about historic practices of high grading, where people came in and focused on the removal of big trees. But now that we can basically remove more smaller trees more efficiently, now we're able to switch our focus a little bit and do more thinning projects in the forest in an economically viable way than we were before. So, there's some environmental concern about driving heavy equipment around in the woods, and certainly the noise from equipment can disturb animals, specifically during nesting season and things like that. But overall, this has generally been considered to be a benefit to the forest industry. Okay. So I will post this video of a harvester on the Canvas site for you guys to look at. But basically, as we said, a harvester can do the job of a feller bencher, but then it also does the job of a processor, where it uses wheels to roll along the log once it cuts it down and then cut the tree at certain designated lengths. So it's a pretty sophisticated piece of equipment. Okay, so the next thing that we would need to do in the forest is move or extract the logs. And so usually we take the logs from where they're cut down to some sort of landing site, which is kind of a bigger, more open site where equipment that can't really move around the steep slopes in the forest can come in. And so there's different pieces of equipment that are used to get logs to some sort of landing site. But typically, or most commonly, are using something like a skidder or a forwarder. So a skidder is basically something that grabs one end of the log, or one end of several logs at a time, and then is basically like a tractor that uses its force to pull the logs, and then one other end drags on the ground, and it then skids them or pulls them out into the landing area. Forwarders are usually pieces of equipment where instead of dragging one end of the log on the forest floor, they're actually picking up logs all the way off the ground, like in the picture in the upper part of the slide here, and forwarding them through the forest in that way. So that might be easier to do if you're doing a clear cut or something where you're really opening up the forest, or if you're working on flatter ground, but it's going to be harder to do on steeper slopes, or when you're doing something like single tree selection. And then in kind of more specific kinds of harvesting systems, like a cable yarder system, which we'll talk more about in a minute or so, you are actually going to be connecting the logs to big cables that are hung through the air, and then the cables that are hung through the air are acting like big pulleys that are pulling logs out of the forest. And then in some very specialized situations, you might even be using a helicopter to try to remove individual kind of high-value logs from the forest. So again, multiple ways to go about achieving this goal. That's going to depend on the site, your objectives, the money that you have, the value of the trees, and other things like that. Okay, I'll put a video of cable yarding on our Canvas site as well, but here's kind of some diagrams and some photographs of cable yarding. The diagram on the top left basically shows you how you would be setting up this big pulley system. Usually today it's done from a piece of metal equipment like a big crane that then is kind of connected by a major cable down to the bottom of the hill slope. And then there's usually a piece of equipment called the carriage that is kind of being moved up and down that big pulley line that usually involves a skyline and a main line. And then that carriage is attached to chokers, which are big metal cables that can be used to wrap around the logs and then pull them up onto the pulleys and then pull them up usually to the top of the hill. So sometimes cable yarding is done in a way where the logs are completely pulled off the ground, and so they're not touching the ground at all, and they're just being lifted through the air, like if you could imagine kind of like being on a ski lift or something. And then in other setups, the line kind of drags the logs along the ground a little bit more like a skidder. And that kind of smaller scale system where the logs are really being skidded up the hill is a little bit more common around the Sierra Nevada, where we do use cable yarding. And other places where they use cable yarding more frequently, then they might have bigger, more sophisticated setups going on. And generally, we use cable yarding in areas where we have steep slopes. For one, it doesn't work on flat ground, but also it's more expensive, and so we usually want to have a reason that we're going to use it, and usually the reason would be that it's a slope that's steep enough that it's going to be difficult for traditional equipment to move around on that slope. And on those slopes, when we do use cable yarding, it's often considered that we're doing a lower amount of environmental damage because we're having less soil disturbance by picking logs up off the ground, not dragging them along the ground as much, and not driving as much equipment around on the ground. So back in the day, before they had these big metal cranes that they used in cable yarding setups, they would actually use trees that they called spar trees to be the kind of locations that the cables were hooked onto. So they talk a little bit about these old spar trees in the Golden Spruce book. Grant Hadwin's uncle was somebody who was responsible for limbing these spar trees and climbing trees. And if you've watched different kinds of logging sports events on TV, ESPN3 or wherever you might see it, you might have seen modern day races where people are trying to climb up these trees as fast as they can. And the idea of this is kind of a reenactment of this old skill set that was used to set up these big cable yarding events. So I'll put a clip of that on Canvas as well. Okay, finally we mentioned that sometimes helicopter logging is used. So helicopter logging is really expensive. Flying helicopters is really expensive. The fuel for helicopters, the insurance for helicopters is very expensive. So we usually have to have a pretty good reason to bring in a helicopter, and that might be that there's high value wood in a relatively remote location. And so, it would be so expensive to drive all the way out there, or it's not very accessible because it's pretty steep, but there's something about the location that makes us really want to get the wood out. And so we do sometimes see this, but it's, again, usually only occurring for a pretty good reason. Okay, so once we've cut down the tree, dragged it to some sort of landing site, then we are going to process the wood. In some cases, the wood may have already been processed by some sort of harvester, but usually it hasn't been very thoroughly processed. And so often a lot of the processing is done at a landing site. And again, processing means removing the tops of the trees, the branches, and cutting the tree bowl into lengths that are desired by a particular mill. So sometimes this is done by hand. A hand faller might bump knots, aka cut off branches, and then buck up the tree. That's the terms we use to talk about cutting the tree to length. But then there's also equipment. We mentioned harvesters already, or another thing that's called a stroke delimber, which you can see at the bottom here. And basically this thing has a wheel, and so it pulls the tree through, and by counting how many times the wheel has gone around on the tree, it can figure out how long a length of the bowl is. So it cuts off limbs as it measures the tree to a certain length, and then it cuts it, and then it continues to cut off limbs and cut the tree again. So it looks pretty similar to a harvester, except a stroke delimber is only doing the processing part and didn't do the initial cutting or felling of the tree. So anyway, that's what processing is all about. Okay, once we get the trees processed, moved to the landing, and then originally felled, then we're going to have to load them onto usually a log truck, could be a train in some other locations. But we're going to be doing a couple things as we load the logs. We're usually sorting logs. So most often an entire load on a particular log truck will all be the same species and may also be grouped by size. So sometimes you see loads of, only 3 huge trees coming in together, or you might see loads of smaller trees but are more similar in size. And so that's often an objective as we're loading the trees, to do some sorting. And again, there's multiple different pieces of equipment: front end loaders, knuckle boom loaders. The knuckle is that piece in the back that kind of pushes against the back of the log as some sort of pincher piece grabs the log and prevents it from swinging around so much. But these kinds of pieces of equipment are usually picking up the logs from the landing site where they've been processed and gathered and loading them onto some sort of truck. Then finally, we have to get the logs to the mills, usually where they're going. Usually that's around here, at least, is going to be done on a log truck. So anyone who lives in Plumas County has seen a whole lot of log trucks. We know what they look like. There's a picture here on the top of the page. It's kind of a pretty typical load of a log truck. In other parts of the world, we might be loading logs on trains instead. Of course, we don't have a very sophisticated train infrastructure in our country at this point, which in my opinion is too bad. And then also we have much more limitations for safety and other reasons on the size of log loads and the number of like trailers that you can be hauling of log loads. So I have a picture down here on the bottom right that you will hopefully not ever see in the United States, because that's a pretty unsafe load that has multiple trailers and logs stacked up very, very, very high. So anyway, you're not likely to see that kind of thing around. That's going to get the attention of the CHP pretty quickly. Anyway, the goal of this is to move the logs into a place where they can be turned into some thing that has some sort of economic or social value to us. So around here, mostly that's lumber, perhaps it's energy, perhaps it's just going to a biomass plant. There's none of these in Plumas County, but it could also be going to make paper or other kinds of paper products, and basically just moving it to the place where that process is going to happen. So in addition, there are many non-harvesting operations that are done in the forest. So when we talked about silviculture, we talked about many intermediate treatments, and some of those intermediate treatments involve thinning, which is a form of harvesting trees in the forest. But we also talked about other processes as well. One thing we mentioned was masticating, when we use heavy equipment to basically chop up the trees into smaller pieces that then can be thrown around on the ground to cover the soil and kind of hopefully remove fire hazard, reduce competition, etc. We also know we do a lot of burning in the forest. In the fall is a time that the Forest Service and other private groups around here do a lot of burning when the nights are colder, the days are colder. Hopefully there's a little bit more moisture in the air and on the ground. So sometimes we burn piles of slash, different pieces of branches and treetops that have been gathered in the forest, or we do broadcast burning. That's where we're burning large swaths of the forest floor like we would see in the bottom picture on the slide. And then another really, really important operation that goes on in the forest all the time is the building and maintaining of roads. So we have a huge number of roads that allow us access to the forest for recreation, for firefighting, for scientific research, and then of course for our forest operations as well. And it's no small task to build and maintain this large road network. So there are 350,000 miles of forest on U.S. Forest Service property. That's a distance that would get you all the way to the moon and halfway back. So that's very extensive. It's longer than the interstate highway system that we have in the U.S. if you add up all these Forest Service roads. And so it takes a lot of time and money to maintain this network that we depend on for a lot of different access issues, as we've mentioned. So roads are often the most problematic areas in forests. A lot of times people see a big clear cut or even a group selection cut, and they imagine like, oh my gosh, that area has been very disturbed. It must be leading to all kinds of erosion. And in some cases that can be true, but for the large part, it's actually the roads, not the areas where the forest cutting is going on, that are actually leading to major erosional and other problems in the forest. So roads are a problem for a few different reasons. The first one is probably pretty obvious, and that is that to build a road, we obviously have to cut down all the vegetation that was in the road before. And so that vegetation, when it was there, was kind of acting as a protective layer over the soil. When, for instance, raindrops hit a plant on their way down to the ground, that slows them down a lot. So by the time the water reaches the soil, it's not moving very fast. It doesn't have as much energy to dislodge soil particles and move them around. So once that vegetation is gone, the soil is going to be more vulnerable. The other thing about roads is once we've moved a whole bunch of vegetation along a long linear stretch, then not only are we going to have raindrops coming down vertically to the soil and hitting it at high speed and dislodging particles, but we're making these large, basically roadways, which is exactly what they are, along which the water can travel. So the water is going to preferentially continue to flow along that road where everything is exposed. It's going to pick up speed and pick up more and more soil particles as it moves and continue to carry them off site. So we'll talk about in a minute, anything we can do to try to get the rainwater off the road rather than allowing it to continue to move along the road is going to help us slow erosion rates. And then finally, when we build roads, we intentionally compact them down so that they'll be a little bit more sturdy. But as we compact the soil on the roads, originally intentionally and then also by continually driving over them, then we're really preventing the ability for water to infiltrate down into the road. So in a normal undisturbed soil environment, raindrops that fall on the soil or on vegetation above the soil will end up getting to the soil and then being absorbed by the ground. So there's not a lot of water left over to be running across the surface and creating problems. But by creating this compact soil environment, we are preventing the infiltration of water and then creating this big pool that then ends up flowing preferentially along this open road, picking up soil particles and creating a lot of havoc potentially as it moves. So as I mentioned, usually what road engineers are trying to do and road layout engineers are trying to do is try to think about ways to direct water off the road so we can get it back into a natural soil environment where there's vegetation, where soil isn't compacted, where there's protection. And so there's different ways that we go about doing this. First of all, roads in the forest are either often outsloped roads or insloped roads. so that if we look across the horizontal stretch of the road, it's actually not flat, but it's either tilting outwards toward the hillside or inwards towards kind of the uphill side of the road. And so, and both of those designs are designed that steepness, the grade of the horizontal part of the road, will ideally, hopefully, be actually steeper than any slope along kind of the direction that the road is moving. And so that when water does fall on the road, it's going to run right off one side or the other rather than down along the road. Outslope roads, like the picture on the left, are a little bit simpler to construct. They're a little bit less expensive, and so that's usually done on smaller scale roads. And then more bigger, more major roads are often insloped, and in this case the water is designed to flow in towards the uphill side of the road and then along some trenches on that uphill side of the road, and then at various places along the road it will flow underneath the road through culverts, right, big round tubes or pipes, and then drain out to the downhill side of the road. So that involves more expensive construction. It involves us maintaining culverts, making sure they're cleaned out so they don't get clogged up. But these insloped roads are a little bit safer and for people to drive on. And so that's one of the motivations that we might use to create insloped roads in more high traffic areas. Other things that we do are water bars, basically where we build little bumps in the road that, again, kind of would prevent water from running down the grade of the road and hopefully direct it off to one side or the other. So there's kind of a joke in forestry that says, like, what are the 3 largest contributors to erosion in the forest? And the answer is roads 1, roads 2, and you guessed it, number 3 is also roads. And so sometimes we could say erosion is the major problem in the forest, not, again, soil that's coming off areas where timber harvesting has actually taken place. And we've all also probably seen places like the photograph that's shown on the right, where when water is allowed to flow down the road and the road isn't maintained, then it can really blow out the road and create these big problems, where now this area is no longer really accessible to people with regular cars. And also we've created a big water pollution problem downstream, where all the sediment is getting into waterways, disturbing fish and fish habitat, macroinvertebrate habitat, and other things like that. So, you know, it would be great if we had time and money to keep all our roads really well maintained, but unfortunately, maintaining roads is a big job, not only because there's so many of them, but it's also really expensive to maintain roads. And so here's just a few examples I pulled off a chart. This is from a few years ago, so it might be slightly out of date, but gives you a general sense of how expensive some of these projects might be. To outslope an existing road might be several $100s per 1,000 feet. And you can imagine you're never just working on 1,000 feet of road. You're usually working on miles of road at a time. Graveling a road can be thousands, up to $10,000 per 100 foot. Installing a culvert is going to be thousands of dollars. So kind of the upkeep of major forest roads is going to be kind of on the scale of $50,000 per mile. And again, if you have 350,000 miles of roads that you're responsible for maintaining, that's a very expensive project for you. And so a lot of times, unfortunately, we have roads in the forest that aren't as well maintained as they used to be, because, you know, we don't have as much budget to do this kind of thing as we did in many times in our country and in our government in the past. So anyway, maybe this is not as of a glamorous of a job as some other things that people get to do in the forest, but it's very, very important. It has huge impacts on environmental processes that are going on in the forest, and is a very, very important job.